So I think knowing how to write a function that helps us calculate the factorial of a number is actually a very good thing, because it shows that we know our maths concept like factorial. We know how to think logically, and we know concepts in code such as recursion loops, do while loops, and while loops. So in this case, we are going to be using recursion. As you can see, the factorial of 5 is 5 times 4 times 3 times 2 times 1. So basically it means you start from the number itself and decrement until you get to 1. Once you have that sequence, you multiply everything together, and that gives us our factorial. But most importantly, we can see that the factorial of 5 in the second line here, so the factorial of 5 is actually 5 times the factorial of 4. So what does that mean? Remember, the factorial is start from the number, decrement, so you get to 1 and you multiply. So it means that this factorial of 4 is 4 times 3 times 2 times 1, which is actually what factorial of 5 was minus the 5. So it means the factorial of 5 is 5 times factorial of 4. Likewise, factorial of 4 will be 4 times the factorial of 3, which is 3 times 2 times 1. So we're going to use recursion to solve this. And as you can see, we've already written our preprocessor header int main void. We've written a function in our main that actually takes n, a certain number which I don't know, from the user and stores it inside the variable n. I'm assuming that my user is going to enter a positive number. So if not, I would have used a do while loop to actually keep asking the user to enter a number until he or she enters a positive numbers. But I'm just making assumptions for now. I'm calling the function which is fact, but we don't know what fact is all about for now. So I'm going to write my function here, and basically what my function is doing, okay, we use num. My function is going to return an integer value, as you can see, and that integer value, we are storing it inside this result variable. So, and what would our function do? So for the first things first, our function is going to check using an if statement if the number, that is if num is equal to 0, or if num is equal to 1. So if we have a case like this, our function is going to return 1, and we're going to break out of the factorial function as a whole. So, but in the opposite case, if we have a case whereby the number is not 0, it's not 1, it means that the number is greater than 1, like 2, 3, 4, 5, 6, and the rest. So we'll just use our else statement to tell our factorial function what to do in this case. So basically our factorial function is going to return this n times the factorial of n minus 1, the factorial of n minus 1. So now this may look a bit confusing at first, but let's take a look at this. Instead of n, we should be using number, since inside the function we actually first declared number. So what are we having here? We have first of all, we are seeing that the factorial function is being called here inside the factorial function. This is why we call it recursion, whereby we have a function that calls itself. So why will this work? Remember that if n is 5, for instance, we know that the factorial of 5 is 5 times the factorial of 4. So that is exactly what we have here. If the number is 5 that came inside the function as an input, we have here that 5 times the factorial of 5 minus 1, which is factorial of 4. Now, so it means that at that first iteration, we're going to have the factorial of 5 waiting somewhere in memory. It's not going to be calculated because we don't know what the factorial of 4 is at that moment. So the factorial of 4 will mean that it's going to call this factorial function again. That's the second time, and in that case, okay, it's going to call the factorial function again, but in that case the input is no longer going to be 5, the input is going to be 4, and we're going to go through this loop until we get to this stage again, whereby we have number times the factorial of the number less than 1, that is 4 times the factorial of 4 minus 1, which is the factorial of 3. So remember that we don't know the factorial of 3, and it means that factorial of 4 is going to be on hold for a while in memory until the factorial of 3 is calculated. So it means we are calling the factorial function again, but in this case the input is not 5, it's not 4, the input is now 3. you say 3, you come down and say 3 times the factorial of 3 minus 1, which is the factorial of 2, and it means you are going to solve, you're going to call your factorial function again, but in this case your input is 2. So you get the idea of a function calling itself. So of course when you get to 2, you are almost done, because 2 minus 1 means you're solving for the factorial of 1, which in this case we've said if the number is equal to 1, you're going to return 1. And 2 times 1 in this case is going to be 2, and it means that the factorial of 3 that was actually waiting for the factorial of 2 is going to have 2 now as its answer. So you can now simplify that and say 3 times 2 is 6. The factorial of 3 is 6. The factorial of 4, when that was in the second iteration that was waiting for the factorial of 3, can now just say, okay, 4 times 6, which is 24. And the first iteration where we had factorial of 5, it was actually just waiting for the factorial of 4, which is now 24, and it just say 5 times 24, which is 120. So if we run this code, let me just save this. If we run this code, we should be getting that the factorial of 5 is actually 120, and I'm going to put 5 here, and I get the factorial of 5 is 120.